Hello guys, and welcome to today's video. And there's some things that I want to go over today that I didn't quite have the time to go over, yesterday. Somebody asked me what the effects of shear and the SAL or Sierra and air layer could do to a system if it was to form this time of year. We will go over that, and obviously we will go over some, SSTs and Nino's 3.4 regions and stuff like that. Obviously, we're on the CDAS 3.4 index right now, and as you can see, we had that slight increase in these water temperatures here in the Nino 3.4 region. But ever since maybe like 2 days ago, it started to go back down again. So now we're getting into the negative 0.942 range here, and I wish I would have brought up the graph to show you guys what's going on within that region, but last here we are. Those graphs, show major easterly wind bursts for the foreseeable future, pretty much. And what that's going to do is that's going to lower these temperatures down in the Nino 3.4 region pretty nicely over the coming weeks and maybe even up to a month, because there was one model graphic that I've seen that showed these easterlies bursting through until about April 7th. So, if everything pans out the way it's going right now, I would not be surprised if we make it to close to strong La Nina, as we get closer to the hurricane season, which so that will have major implications because, weak and moderate La Ninas, those are typically the best, and plus cool neutral, are typically the best for Atlantic, activity. But if we get a strong La Nina, that just reverses everything. Strong La Nina, due to popular belief, is actually bad for the Atlantic when it comes to activity. It seems like everything reverses once you get to that strong La Nina threshold. So we'll see how that pans out as we go out through the next several weeks and months to come. All right, so here is the sea surface temperatures for the 12Z on the 13th, which is today. And as you can see here, some of you guys know that a cold front came through, not too long ago, and it actually brought really cold temperatures to Florida. But as you can see here, the sea surface temperatures really hasn't changed at all, which is amazing, really. I would have thought that these temperatures would have fell off by now, but here we are. They're still kicking it and warm in a lot of these areas, and you can see some 28.5s here in the Caribbean here, and you can see these 27s also working in farther north into the Gulf of Mexico as we go through time, and then you can see where the Gulf Stream is pretty clearly with the warmer sea surface temperatures that are being represented here. There's some 26s, 27s even in the Keys. So, this cold front really didn't do anything to the sea surface temperatures here in these regions. They're still rebounding pretty nicely, and I'm getting worried about how hot these sea surface temperatures are going to be by the time hurricane season comes, because they're already creeping up there like really warm right now. So we'll just have to, like I said, pay attention to what's going on there. All right, so here are the sea surface temperatures for the tropical Atlantic. As you can see, these sea surface temperatures are starting to creep up above 10 north now too. So, it's going to be pretty interesting to see how this all unfolds too. As you guys know, at the start of the year, say like January or February, these sea surface temperatures were actually pretty warm. But ever since then, they took a major drop off in temperatures because of the easterly wind bursts that continue to come through the tropical Atlantic here. But as you can see, 28s, 27s, 26s are still on the table here in most of the main development region, the western main development region, I should say. So, most of these areas are pretty much, good for tropical development if there wasn't any wind shear or air layer around. There's a lot of dust out there, believe it or not. It may not look like a whole lot to the untrained eye, but once we get into some of this graph here, this Sierra and air layer Go 16 split window, we're gonna see how much Sierra and air layer is in there. And speaking of shear, we are going to take a look at the CFS bulk here. And obviously, we're not going to take this very seriously. This is for an example that I'm about to make. As you guys know here, these blue anomalies here or is favorable shear. So we got pretty favorable shear here in the MD, some portions of the MDR and then some portions of the subtropics. But then you got a major spot here in the Caribbean and the Bay of Campeche of very favorable conditions too. But when you see these reds, these are very unfavorable, wind shear here. So if you get a storm that comes off, it's gonna blow the cold cloud tops away from the center of circulation, and we're going to see an example of this here shortly. These winds are blowing out from the east here, and so what that's going to do is it's going to blow that convection to the west a little bit, and then it's going to make it look like a whole mess, kind of thing. And we're going to give you an example. And well, obviously, this is already a hurricane at this point, but it's still an example of wind shear and how it works. So let's take a look at that right now. All right, so this is Hurricane Maria as it travels to the Turks and Caicos here, and as you can see, obviously this was a cat high end cat 4 or cat 5 in some people's eyes that went right through Puerto Rico. That it wasn't a good look. Um, that Puerto Rico got devastated and the such, and you hate to see something like that happen. But that was about 5 years ago, coming up this summer, and as you can see here, this is definitely not as healthy as it was, during his time in Puerto Rico. You see that the eye has clouded over, and you see this convection that is spawning out, into the northern sections of the storm. That's the thing with wind shear is, you see the convection, weighing off into different directions. It's not like a nice circular system that the hurricanes are typically meant to be. Um, this is the direct results of, I think, southwesterly shear. I mean, I could be wrong on that. As you can see, it's south to southwesterly shear. That's what causes this right here. So that can weaken a system quite dramatically, depending on how the structure of the eye is, and how the convection is holding up to that core, that center of circulation. Because that goes into my next thing. That's dry air and Sierra and air layer, because that wind shear is the driving factor pushing that dry air and air and dust inside of a storm. So we're going to take a look at the Sierra and air layer here, and as you can see, that's a lot of dust that's around in the Atlantic right now. This is definitely not a favorable look as we look at it right now. But as we go out through time, this is going to start evading a little bit and pushing up north, and less of it is going to start coming off, and that's typically around July, August, September, when we get to towards the peak seasons. That Sierra and air layer is not as prominent as it is during the early season and the off season of the hurricane season. Unfavorable look here. There's tons of dry air and dust here in the Bay, Campeche, and the southwestern Gulf of Mexico. Tons of dry air and sail here when it comes to the MDR region, and the only place that may be semi favorable for any development right now is the freaking Caribbean. And even that, that goes back to the wind shear. There's just way too much wind shear right now for anything to really take advantage of, these small spots of moist air that the Caribbean does hold. But, you know, most of the tropical Atlantic is shut down and not favorable for business at this time. Obviously, I'm going to check in with this every day to see how this evolves. And, I'm going to be making updates almost every day to every other day. So we'll go over this together as we go out through time. So when we speak SAL, systems do not like SAL. SAL might be its worst enemy more than Shear is. And we're going to take a look at an example of that right now. This is what was to become Hurricane Aaron. And as you can see here in this first picture up here, and I'm sorry, this is like really bad quality. This is the best example I could get at the quality. As you can see, there's SAL, you know, on the north side, west side, switching into the south side here. And that's what's keeping, Aaron at bay here a little bit. So as you guys know, these systems moisten up the atmosphere. So obviously, Aaron is going to eat away at some of the SAL, but it's going to keep Aaron from you know taking full advantage of this environment that it has, and that goes into picture number two here, down in the middle. As you can see now, this Aaron air layer is pretty much surrounding Aaron now, and it's not really giving it room to breathe at this point. But as you guys know, these storms are fighters. We've seen, tropical cyclones fight through SAL. We've seen them fight through wind shear and whatever other, obstacles that come their way. As you can see, it finally escapes from the SAL, and then you can see that Aaron is now a full-fledged hurricane with an eye right in the middle of it. So now we've seen how SAL and Shear affects the development of these systems, or hampers it a little bit in some regards, even later in their lives. So I always think that this is a very interesting thing to study. You know, it keeps my mind busy, and I get to help you guys know what SAL and Shear does, and these are going to be a big thing going in towards the hurricane season. So we'll see how the SAL and the wind shear evolves together throughout these updates. Anyways, I want to thank you guys for watching once again, and I will see you guys on the next one. Have a nice day.